looking at sine, where is it? Sine square theta plus 3. And then I'm going to swap out that part. So I'm going to have 1 minus 2 sine square theta. And that is equal to 2. All right. So that's what we have. So this is good for us now, because I can see that I have a sine here and I have sine here. So because I have the same thing, I'm good to go. I think I can push through. No, understand? So what we're going to do though is just to distribute. Why not just distribute the 3 inside ordinarily? Let's distribute our 3 there and distribute our 3 there to clear up things and get rid of the bracket. So we're looking at sine square theta plus 3 minus 6 sine square theta equal to 2. So after the first step, that's what we're looking at. Now, from here, we're organizing ourselves, you know. I would want to get rid of this. So basically, I'm looking at, and I want to simplify in the meantime, because we're looking at sine square, sine square. We have a positive 1. We don't write 1, but that's a positive 1. And this is a negative 6. So you could see we're putting it together, we're getting negative 5 of that. So basically, this is negative 5 sine square theta based on what we simplify there. And then this is equal to 2. We subtract 3 from both sides. Yeah, subtracting 3 from both sides. So you could see that going on right there. So basically, we have negative 5 sine square theta equal to negative 1. Divide both sides by negative 5. So you would have sine square theta equal to 1/5. And at the same time, we intend to get rid of the square, because a lot of times people don't realize that sine square theta really means sine theta square. That's what it really means. So in order to get rid of the square, we're going to have to take the square root of both sides. Remembering that whenever you use the square root, not if you see the square root in the math already. If you were the one who wrote it, you have to write plus or minus in front of it. Because you see, when you get it from them, they will know if they want plus or minus or just plus. But if you are going to write it, then you're going to have to use a 2. So then, sine theta, no. Hold on, let me fix this. This is ugly. Sine theta is now equal to plus or minus the root of 1/5. So that's what we have right there. Now let's talk about this. If you're moving from 0 to pi, all right? If you're moving from, say, 0 to pi, we will be basically in the second quadrant. And by the time we reach in the second quadrant, sine is positive here, sine is positive here, sine is negative here, sine is negative here. So then the plus or minus, no, you're going to have to think about these ideas. You don't just run with them. It is in context of where the question wants us to go. The question says that we are working between pi and 0. So then we are only working in this segment. We're moving from here to here because they're talking about sine. Sine is positive here, it is positive there. So the two negative responses are not applicable for the angle that we're functioning within right now. Therefore, we're embarking on finding sine inverse of the root of 1/5. 1/5. Radians, what we get?
0.46. Yes, sir.
All right, good. That's correct. 0.46 is good. So 0.46 is good. And that is the first answer. So remember now, we have two pieces. One is going to fall here, and we're going to have to math out how to get this one. Remember that? We normally subtract the acute angle. So basically then, let us say the one that we just got, Abriana, is 0.46. And we will have a related angle over here, but the 0.46 is here. So you subtract it from pi, and it gives you that. Remember that idea?
Yes, sir.
So it's going to be pi minus 0.46, and we will get the other one. So you can...
I got 2.68.
2.681.
Yes, sir.
All right, so let us represent properly. Because it says 1 dp, then the first answer is 0.5, and the second answer is 2.7. Very good. Remember, if you get this to prove, it's like you take the left-hand side here and you manipulate it. So you manipulate the left-hand side, and at the end of the day, show that you get this, and you're good. Manipulate it and show that you get that, and you're good if you can do that. So then what we're going to do now is to take, we're going to work out, make this a single fraction, because we have two fractions on the left side, but on the right side, I have a single fraction. So I'm going to try to make this a single fraction, which means that I'm going to employ a quick cross multiplication thing. For those of you who know this, we spoke about this sometime. This multiplied by this minus this times this over this times that. So that's the same thing as using the regular fractions, right? So then we will have 1 times this down here, which is 1 plus sine x. The minus sign is there. So we have minus 1 times this all over the two bottom things multiplied. So 1 minus sine x times 1 plus sine x. This is the difference of 2 squared. A plus and a minus between the same thing. If I distribute the 1 inside here, I'm going to end up with 1 plus sine x. And if I distribute, I'll have minus 1 and a positive sine x all over. When you multiply this, it's a difference of 2 squared. We'll get 1 minus sine square x. One would now notice that positive and negative 1 cancel themselves out. So then we're now left with sine x plus sine x, which will give me 2 sine x over 1 minus sine square x. Remember though that sine square x plus cos square x equal 1. Cos square x is 1 minus sine square x. This is we could take this and plug it here. because it is not. Why am I doing it? Because I am going towards tangent. Tangent is sine over cos. And I'm now seeing where I could get a cos under the bottom, which is what I want. So this is us doing whatever we have to do to survive. So now, if I am rewriting this, I'm going to say 2 sine x all over cos square x. Almost there. Because I'm seeing where now I could say, oh, if we really look at this, if you really look at this, then you're seeing where you could split this as 2 sine x over cos x times 1 over cos x. I want you to see how I manipulated this, just because I know that this part is tangent. It is still under there, but I'm splitting it. So if you try to work it backwards in your mind, we didn't change anything, but we flip it so that we could get 2 tan x times 1 over cos x. Can you see that now?
Yes, sir.
Yes, sir.
Yes, man. So we're seeing that right there. And then now you could see that this is over 1, right? So then it's done, because now we're seeing where we have just proven that 2 tan x over cos x, which is this.